Hello everyone, I am Abrar Rahman Abir, undergrad student of Computer Science and Engineering from Bangladesh University of Engineering and Technology. Today I'm going to present my poster entitled Deciphering the Twists of RNA, RNA Torsion Angle Prediction with Attention-Inception Leveraging RNA Language Model. So what was the motivation of our study? There are 7 torsion angles of a RNA molecule. They are namely alpha, beta, gamma, delta, epsilon, zeta, and chi. All these 7 torsion angles are directly connected to the three-dimensional structure of RNA molecule. Moreover, the three-dimensional structure of RNA molecule influences the stability, the function, the attributes, and the interactions with other molecules. So it is critical to determine the 7 torsion angles as well as the three-dimensional structure. Despite the significance, the accurate prediction of RNA torsion angles has not received much attention in compared to protein. There are many good models that predict the torsion angles of protein quite accurately. So if we have the correct or the precise measurement or the prediction of RNA torsion angles, it can help significantly in personalized medicine and therapeutics, which are RNA based. So here I list the contribution of this work. First of all, here we present a novel deep learning model that accurately predicts the 7 torsional angle of RNA from sequence data. And as far as input features are concerned, we have integrated physicochemical properties and the language model RNA-FM embeddings. And in our architecture, we have introduced or integrate transformer encoder, a 2A3I DC block, which stands for Tension Augmented Inception Inside Inception with Dilated Convolutional Neural Network, to capture the local and long-range dependency of the sequence. We have evaluated our model against the benchmark spot RNA 1D, and we have showed that our model significantly outperforms the spot RNA 1D. So we have used the dataset employed by spot RNA 1D, which contains 286 sequences as training dataset and 4 distinct test sets. The test sets are namely the VL, TS1, TS2, TS3. It's containing 30 to 63 sequences. The DSSR program have been used to determine the torsion angles from the sequence. So now coming to the methodology. Here I present the inception block, the 2A3I DC block, and our overall architecture. So in the inception block, here we see the input is passed in 2 parallel paths, each having the convolutional neural networks, and the output is concatenated at last. So this is the notation of the multi-headed attention block. Now coming to the 2A3I DC block, there are 2 parallel paths and they are identical. So the input feature is at first passed through the inception block. And why we call it inception inside inception? Because inside this inception block, which we see in this figure, there is also another inception. So after passing through the inception, the features are then passed through the dilated convolution neural network, which is followed by the multi-head attention block. So we then concate the 2 output paths features. So here is our overall architecture. As I have mentioned earlier, we have used the RNA-FM embeddings on the physicochemical properties and input features, which we pass through the transformer encoder to capture the local and long-range dependency of the sequence. So after passing through the transformer encoder, we pass it to consecutive 2A3I DC blocks, which is then followed by a multi-head attention block, and which is again followed by a convolutional neural network. Then we have another attention block, which is followed by the dense layer. And at last, we have two components, one attention block and one final desk layer, which has 14 nodes. Why 14 nodes? Because there are 7 torsion angles and we predict the sine and cosine of the 7 angles. So 7 times 2, we have 14 output regression nodes. So after getting the sine and cosine of the angles, we perform the arctan to get the accurate angle value. So here we present our result. We see that here we basically plot the mean absolute error of the predictions. The red one is of the spot RNA1D and the blue one is our model. We see that our model consistently achieves lower mean absolute error than spot RNA1D. Moreover, we see that it is really difficult to predict the angle alpha, which has the highest mean absolute error. So to coming to the conclusion, we have developed a deep learning model that correctly predict the 7 torsion angles of RNA from sequence data. Our future work might include transformer as the backbone. So here is all. Thank you everyone. Good luck.